Hello, my name is Dr. Timothy Yateman, and I'm a professor at the University of South Florida and Associate Center Director for Translational Research and Innovation at the Tampa General Hospital Cancer Institute.
Hello, I am Dr. Soundararajan, a research scientist at USF.
I am Michelle Maurin, a research scientist at USF.
Colorectal cancer is the third most common cancer in the world and the second leading cause of cancer-related deaths in the United States. Over a century ago, Virchow proposed that cancer represents a chronically inflamed, poorly healing wound. Normal wound healing is represented by a transitory phase of inflammation, followed by a pro-resolution phase with prostaglandin E2 and D2 induced lipid class switching, producing inflammation-quenching lipoxins such as LXA4 and LXB4. In this article, we've hypothesized that lipid dysregulation in colorectal cancer is driven by a failure to resolve inflammation. We performed non-targeted and targeted tandem mass spectrometry analysis of human colorectal cancers and normal paired samples, integrating lipidomics with quantitative RT-PCR, bulk RNA sequencing, and spatial transcriptomics with public single-cell RNA-seq data, characterizing the expression and localization of genes that produce lipid mediators.
Volcano plot depicts the upregulated and the downregulated lipid mediators in normal and tumor samples. A significant increase in myristic acid-bearing sphingomyelin and phosphatidylcholins was seen in tumors relative to matched normal controls. Our data showed that the pro-inflammatory lipids 5-HEAT, the precursor to LTB4, as well as LTC4, D4, and E4 were significantly increased in tumor versus controls. On the other hand, pro-resolving mediators such as 11-HEAP, LXA4, and LXB4 were not overrepresented in tumor compared to the normal samples.
Secondary analysis of Moffitt, Merck, and Marisa datasets shows increased expression of ALOX5, ALOX5AP, LTA4H that synthesized LTB4, whereas pro-resolution enzymes ALOX12 and ALOX15 were weakly expressed. Real-time PCR data analysis revealed an increased expression of ALOX5, ALOX5AP, LTA4H, and LTB4R in colon tumors versus matched controls. Single-cell RNA-seq data analysis showed upregulation of genes producing LTB4 and its receptor LTB4R in myeloid compartment, suggesting an inflammatory milieu in colorectal cancer tumor microenvironment.
Lipid chromatography mass spectrometry analysis reveals low levels of PGE2 and PGD2, which cannot be attributed to an increase in PGE2 degrading enzyme HPGD. Single-cell RNA sequencing analysis shows poor expression of genes associated with lipid class switching such as LOX12, LOX15, IL4, and IL13. This, combined with an inefficient PGE2, PGD2 signaling through their respective receptors, PTGR2, 3, 4, in tumor versus normal may be indicative of defective lipid class switching.
Spatial transcriptomics analysis shows an increased colocalization of ALOX5 and ALOX5AP in colon tumors with higher levels of LTB4. Quantitative analysis by cluster showed a significant increase in ALOX5, ALOX5AP co-expression, with ALOX5AP as a main determinant for LTB4 production in high LTB4 tumors versus low LTB4 tumors.
Normal wound healing is represented by a transitory phase of inflammation followed by a pro-resolution phase with prostaglandin-induced lipid class switching, producing inflammation-quenching lipoxins. We propose a new harmonized preclinical and clinical colorectal cancer model of defective lipid class switching attributable to the reduction in ALOX15 expression, whereby arachidonic acid excess may contribute to the observed lipid class imbalance. These data raise the possibility that Western diets containing excessive omega-6 levels could contribute to the pro-inflammatory state seen in many colorectal cancer patients. We thank the editorial board of Gut for this opportunity to present our visual abstract.